Hi, Princeton Tigers. Okay, so today we're going to be reviewing square roots and cube roots. Two of you guys went over cube roots with me yesterday, but a lot of you haven't done it yet. So just make sure you're paying really close attention while we go over in the video today. So first, let's get this down in your notes. The square root of a number is the number that when multiplied by itself 2 times gives that number. So the square root of 16 is 4. Because if you multiply 4 by itself 2 times, it gives you 16. So go ahead and pause the video and copy down this definition. All right, now for our second definition, we have cubed root. So the cubed root of a number is a number that when multiplied by itself 3 times gives that number. So the cubed root of 64 is 4 because 4 multiplied by itself 3 times gives you 64. Remember, 4 times 4 is 16, times 4 is 64. All right, now let's go ahead and do some practice problems. So the first question says, what is the cubed root of 8? So we can express this in words, or we can express this like this, the cubed root of 8. So that means what number, when multiplied by itself 3 times, will give you 8. Let's see. First number I think of is 4. Okay, what if the answer is 4? 4 times 4 times 4, that would give us 16 times 4. Nope, that's too big. So it needs to be smaller than 4. Let's try 2. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is what? 8. So the cubed root of 8 equals 2. Go ahead and try the cubed root of 27. What is the cubed root of 27? The cubed root of 27 equals 3 because 3 times 3 times 3 equals 27. 3 times 3 is 9, and then 9 times 3 is 27. All right, now moving on to the next problem. It says, what is the square root of 16? Looking at our definition, the square root of 16 is the number that has to be multiplied by itself how many times to get to 16? Right, it has to be multiplied by itself twice. So what number can be multiplied by itself twice to get to 16? 4. Go ahead, try the square root of 25. All right, the next problem says, which of the following are perfect squares? We have 4, we have 1, we have 8, and we have 16. So which of the following are perfect squares? Try this on your own. The perfect squares are 4 because it's 2 times 2, 1 because it's 1 times 1, and 16 because it's 4 times 4. Looking at the next one, which of the following are perfect cubes? So now we have 27, 9, 64, and 125. Which of those numbers are perfect cubes? Go ahead, try it on your own. The correct answer is 27 because it's 3 times 3 times 3. 9, does 9 work? No, because there's no number that multiplied by itself 3 times gets you 9. The first one you might think of is 3, but if you put in 3 times, you end up with 27. What about 64? Yep, 64 is equal to 4 times 4 times 4. What about 125? Yep, 125 is equal to 5 times 5 times 5. So the correct answers are A, C, and D. All right, finally it says place the square and cube roots on the number line below. The first thing we need to do is solve them. So we have the square root of 16. What does the square root of 16 equal? The square root of 16 is 4. What is the cubed root of 64? Yep, it is also 4. What is the square root of 25? It's going to be 5. What is the cubed root of 1? Will be 1. And then what is the square root of 9? You'll get 3. So go ahead and place all of these numbers on your number line. All right, once you get to the back, you're going to be doing just the practice problems that you've seen, similar problems every day. I want to make sure we're doing one thing right, though. So when you're doing the cubed part at the bottom, make sure that you're actually multiplying it out. So if it says 1 cubed, that's 1 times 1 times 1. So make sure you're multiplying 1 times 1 is 1 times 1, which is 1. If it says 2 cubed, do 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. 3 cubed is 3 times 3 times 3. 3 times 3 is 9 times 3. So make sure that when you're doing the cubes, you're multiplying that out, because that'll help us with our problems when we get together at the end of class. Okay, good luck, and finish up the back side of the worksheet and then go on ST Math.